Geology and Environmental Sciences Department. He specializes in geographic information systems, commonly known as GIS, and human environment interactions. And he likes rock climbing and biking. And when he's not doing that, he's researching public and private protected areas, climate change policy and the impacts, and also using drones to monitor terrestrial change. And he's going to present to us today, and let's just give him a warm welcome. I'll stop sharing and then you take over. Thanks, Eric.
Well, thank you, Lita and Diane, for setting this up today. Let's see. Do you see my screen? It's saying screen sharing, but I don't see the right. Do you see your presentation?
Not yet. I think it looks like you're on your desktop, so you might want to.
There. Hi, Grandpa.
Let's try this one more time.
Hi.
All right, how about that?
That's it.
Oh,
Thank you.
my dog is saying hi too. Hey, Odie.
All right. Well, everyone, I'm going to go ahead and mute folks that are in the background. So if you do want to ask a question, feel free to unmute yourself. But just to minimize the background noise, this is what I would do or have been doing with all of our online teaching. So don't feel offended, but feel free. With a small group, we can definitely do questions if you have some while I'm presenting. So, but I'm just going to hit mute all for right now, but you should be able to unmute yourself. And I also will pay attention to the chat box. So if you on your device can open the chat box, feel free to send me a chat. If I can get that to come up. There we go.
Eric and Eric.
Okay. All right. So let me yes, I do this every day. Hold on a second. Okay, how about that? Can you see a picture of climate change in the future of winter recreation in Wisconsin? Okay. I'm going to be presenting work that I've done with several of my students. So Whitewater is a college that we try to integrate students into just about any of the research projects that we work on. And this is a really good example of that. So I'll mention several times Eric Passler, the undergraduate research student who has done a lot of the work that I'll be presenting today, particularly on the winter recreation. He skis the Birkebeiner every year. So when I proposed this idea to him, he was completely sold on it and has been an incredible undergraduate research student. And he's just a junior at UW-Whitewater studying geography. So I'm from the Geography, Geology, and Environmental Science Department. I'm not a climate scientist, so let me be clear about that. What I know how to do really well is manipulate maps and the data that go behind maps. So that's that geographic information systems that Lita had in my introduction. And so the climate scientists really focus on creating these models. And what I'm doing is taking these models and using them in a way to try to look at what will happen in particular places for particular human activities. And today we're going to talk about winter recreation in Wisconsin, something that's really important to Wisconsin culture and tradition, and what might happen to those cultural traditions moving forward. Now, most of you pay attention to the news enough to know that we're getting quite a bit of evidence of climate change being real. We're breaking records all the time in terms of temperature, the hottest August on record, the hottest September on record, and paying attention to some of the events, the fires that we see in California, Colorado, Australia, the significant number of hurricanes. We've just broken the record for the number of named tropical storms. All these are pretty significant indications that climate change is happening. Now, each individual event, of course, we can't prove that that individual event is due to climate change. But when we look at the pattern, it's the long-term pattern that we start to get worried about. And then here's Wisconsin. It's fall. For the most part, we did have this little bit of heat wave, but we tend to get kind of an Indian summer in the fall. Things seem to be like clockwork, like they've always been. And so, probably if we walked around and asked people in Wisconsin of whether or not they think they're personally experiencing climate change, a lot would say no, that it seems like it's always been. Winters we still get snow, we still have to shovel our driveways. And so what we wanted to do with our research was look at the climate change models and look at when we might start seeing concrete evidence in the state of Wisconsin, but also ask people that are involved in winter recreation. So this is one of those activities that you would think would be particularly sensitive to climate change. Are they noticing anything that maybe the general public isn't? So we did a combination of GIS analysis, this looking at the maps, and then we also did a survey of park and county recreation managers across the whole state. And that's what we report on today. So we're going to talk a little bit about the data that we're using. These are called downscaled climate change models. I want you to understand some of the limitations of some of the data that we're using. And then I'll probably skip this stuff on agriculture. There's kind of two main questions we've looked at: agriculture and winter recreation. The agriculture is nice because it gives you a glimpse of how we can use this data. And then we'll focus most of our time on Eric's research on winter recreation. And again, all of this has come from teaching. So the downscaled models and how to use them, I teach a class on environmental GIS. So we spent a semester with our students figuring out how to import and analyze these data sets. Another student in a sustainability class looked at climate change and its impact on agriculture. And then Eric, through our undergraduate research program, has done this winter recreation study. So downscaling. When you hear about climate change models, most of them are global in scope. These are called GCMs, or global circulation models. And they are pretty coarse. So if you look to the left here, let me get a little cursor that you can see a little bit better. If you look to the left here, the grid cell size is pretty large. So all of Wisconsin's covered by about 6 cells. And the model will say on a given day that this cell is going to be an average of 90 degrees. And that's what they're meant to do. But we know that when you experience climate, it's the extremes that really matter. That if the average is 90 degrees in that cell, that some place is going to be warmer and some place is going to be cooler. And we want to understand those extremes and where they might occur. So downscaled models try to interpolate from this coarse scale to something more fine. And this has been done with a variety of different techniques. We're using something called a LOCA version, a localized constructed analogs. Again, this is work that other researchers have done. And what they do is they look for a day in the climate history of Wisconsin that looks similar to this. So they found this day, and it leads to the same or similar averages. And so they replace in the downscale model this analog for that given day. And going day by day through all the climate change predictions, come up with these analogs. This is how weather is predicted weeks out, months out. And so this is a common procedure within climatology. And this better captures those highs and lows and gives us a sense where we might get some of those extremes. And we can use this data to ask questions about what might happen in particular places. There are some caveats that come with this data. This would be just one realization. There's multiple realizations that would yield these averages. So there's some variability here that mean we can't look at a particular spot and use this model to predict what will happen in that particular spot. But it does allow us to look at kind of regional trends. And that's how we'll be portraying the data today and using it. This is a video that shows you 1 year's worth of that data. So just you can get some sense of what this downscaled data looks like. So this, I think, is modeled 2060 for Wisconsin. And it'll go really fast. So that's 365 days of modeled data and the temperature on any given day. So with that, again, using our software, we can ask questions like, how many days will Milwaukee be above 100 degrees? Or how many nights will be above freezing in winter? Or for the area we grow corn, when will it get above a certain temperature and below a certain precipitation amount, and then map that through time. Now, of course, with climate change models, there's different scenarios. There's different potential futures that we model. And most of these are guided by an international research collective called the Intergovernmental Panel on Climate Change, so this IPCC. They come out with significant reports every 5 or 6 years. We're using data that's from the 5th report. This is the last published report. Currently, they are working on the 6th report, which is not out yet. And the data that we need is not yet available to do this downscale modeling. So this is the data is a couple years old, but there haven't been too many changes between these iterations. So this is still pretty close to what we consider kind of the best science about climate change and modeling it. They came up with 4 different scenarios, future scenarios. These have, of course, a wonderful academic term to name them, representative concentration pathways. And they represent how much heat gathering capability the atmosphere has. So there's low heat gathering at 2.6, that's 2 watts per meter squared, up to a really high heat gathering of 8.5 watts per meter squared. So this kind of models futures of something that would be a dramatic reduction of CO2 emissions. So this is kind of our super sustainability model. Then there's a slightly rosy scenario. This is the closest one to if we all across the globe, all nations across the globe, met our Paris Climate Accord targets. This is a moderate CO2 reduction. So this is RCP 4.5. Then there are 2 less rosy scenarios. There's one that's 6.0. Depending on where we look, some people call this the business as usual if we kind of continue on the path that we're on. And then there's a really worst case scenario at 8.5, kind of a doomsday scenario if we continue increasing our CO2 emissions. In some research, this last model is also called the business as usual, but recently people have said that we probably aren't going to be that bad. But in the literature, it's these 2 scenarios that I have in bold, 4.5 and 8.5, that people typically look at. So to kind of limit how much computer work we had to do, those are the 2 that we focused on, just like a lot of other research projects are. So something that's slightly rosy, following the Paris Climate Accord, and something that's kind of worst case scenario if we continue our CO2 emissions. So I'll be presenting 2 different models for each of these questions. One that's, again, Paris Climate Accord, and one that's a doomsday scenario. So our first glimpse, before we get to the winter stuff, just to give you an idea of how this works, we know that corn, so a key agricultural product in the state of Wisconsin, can't take too much heat during a key portion of its growing season. So when it's pollinating, the pollen can be killed if it gets too hot, approximately 5 days at 95 degrees or higher. And that warm temperatures in general reduce the yield of corn. So over to the right is a bunch of empirical measurements. These are actual yields across Illinois at various high temperature rates. So as the temperature gets higher, the yield goes down. And so we're going to use this curve to get a sense of how much corn production might decrease under various climate change scenarios. So for this first glimpse, we asked the question, what is the average July maximum temperature for these 2 climate change scenarios, and what might be the potential impact on corn yield? So this will be it's kind of the same pattern that we'll look at for each of these different scenarios. So this is looking at the average high temperature in July using that Paris Climate Accord, that RCP 4.5, every 20 years. And so I can see my legend over here on the right, going from a high temperature of about 78 degrees up to 100 degrees. And then it may be difficult to see on your screen. On this first image, there's kind of a green haze here. That green haze is all the places that we grow corn in Wisconsin. So that's the corn growing area. And then if you kind of follow that through time for this climate change scenario, obviously the average high temperature in July gets warmer and warmer. Now, interestingly, under the RCP 4.5, the worst decade is 2080, and it actually starts to improve by 2099. And if we interpolate to what that would mean for corn yields, that in 2080, we'd have about a 20%, so about a 1/5 decline in corn yields. If I look at just the corn growing area, that's what our graph here is. The mean temperature is for each July from 2020 goes from about 86 degrees up to just below 90 degrees. So we're not yet to that 95-degree threshold. So we just see a mild decline in corn production. So this is a future that corn could continue to be produced in Wisconsin, but we would see yield declines, but not something that would perhaps require us to switch crops. If we look at the 8.5 scenario, that doomsday scenario, things don't look so rosy. Things go from moderately bad to just a future that we don't want to see. So by 2100. And this is where the average high temperature in July is getting close to 95 degrees, which would mean that we'd have about a 50% decline in corn production in the state of Wisconsin. So that would mean most likely having to switch the crops we produce across the state. So this is the kind of analysis that we get when we look at these climate change models and ask these very specific questions. Okay, on to the kind of the main body of our study, the winter recreation and climate change. So again, what we did was two different components. We took a survey of all state parks and county recreation departments in the whole state. So that's 153 different units. We got 85 surveys back. That's about a 54% response rate. For surveys, that's actually pretty high. And it's always hard to get people to respond. There were some concerns, of course, about anonymity. And so we had some people concerned about how they might be perceived if they responded and talked about climate change at all. In the survey, we asked them about winter recreation activities, how they might have done adaptation measures. So if they've seen a decline in, let's say, snow or an increase in temperatures, had they done anything to try to mitigate the impact of that, to minimize it? We asked them questions about their perceptions in the past 10 years and what they think might happen in 10 years moving forward for various winter recreation activities. So this is things like ice fishing, cross-country skiing, snowmobiling, hockey. And so were they noticing for these activities changes in the last 10 years and the future 10 years? Now, in order to preserve an anonymity for our respondents, we grouped the state into 3 zones. So a southern zone, a central zone, and a northern zone. And we know by looking at our climate change data that these are going to be experiencing similar types of changes. Most of the changes are going to be happening in the south, few are going to be happening in the north. And this allowed us to report by geography without revealing an individual's response, something we promised when we did the survey. We also did the same kind of downscale climate change analysis. And here we were looking for something that was a proxy for the amount of snow that would be on the ground. Now, the climate change models don't specifically say if it's going to be precipitation, if it's going to fall as snow, or how long it's going to stay on the ground. That's a much more complicated type of analysis to do. So our proxy for winter and snow was looking at the number of days at or below 0 degrees. So this is the low temperature at night. Did it get below freezing? And if it did, then snow is likely to be maintained on the ground. So we looked across the winter season, December 1st to March 31st, and counting up the number of days across the state where the low is below 0. And that's our proxy for winter and if there's changes in winter. So first, looking at the survey results. And this is going to take a little bit of time for you to kind of absorb. So I'll kind of walk you through what we're showing here. So this is looking just at cross-country skiing. So we looked at several different activities and the patterns are fairly similar. So this is kind of indicative of what we got for the other types of activities. We're looking at the survey results by zone. So we've got zone 1 is the southern zone, zone 2 is the central, and zone 3 is the northern zone. And then asking the managers questions like, please estimate the change in the number of days that you're able to go skiing in the past 10 years. So one response might be that they don't think there's been any change at all. So the number of days that you could ski 10 years ago is the same you could ski in the last winter. versus a 10% increase, or sorry, a 10% decrease, an 11 to 25% decrease, a 26 to 50% decrease, and all the way to a more than 50% decrease. And what we notice is in the southern zone is where we see managers saying that they are noticing a difference already, that they already in the last 10 years are, the peak here is an 11 to 25% decrease in the number of days that people can go cross-country skiing, with one unit reporting more than a 50% decrease. Now, if we switch to zone 2, we also see most of the peaks here in the decrease. And it's only when we get to zone 3 do we get more than in the middle. And in some cases, we're actually seeing some people saying that there's been an increase in the number of days that people can go cross-country skiing. And that is actually matches some of the climate change models, that we would get more winter precipitation. So up north where it's still cold, that may mean there's actually more snow on the ground. So that's looking in the past. So this already gives us the indication that managers are noticing the impacts of climate change already. Now, we also asked them about their anticipated change in the future. So what is the public perception on what climate change will mean for Wisconsin? And again, we see a similar pattern. So again, looking by the zone 1 being the southern zone, we see most people actually say that they don't anticipate any change at all, but those that do report a change see again a peak at this 11 to 25% decrease for the southern zone. So it's the southern part of the state that managers anticipate most of the change. Zone 2 is similar. So the central zone also anticipates 11 to 25% decrease in the number of days that you can go skiing. And it's only in zone 3, again, the northern, that they anticipate no change or actually an increase, a slight increase in the number of days. So the perception of climate change, again, looks like it's going to impact the central and southern portion of the state, and the north may be relatively immune for a while. So that's the perceptions of managers on the ground. Now, one of the things that we were surprised in when we did some preliminary work is that we thought we could look at the actual number. Like, we wanted to count the number of days people would go cross-country skiing and the number of events that were canceled and so forth. It was really difficult. Counties and state parks don't keep that kind of information. So it is really difficult to look across 10 years, 20 years to actually count the number of days that cross-country skiing was viable. We're not keeping those kinds of records. We also look at event cancellations. So anecdotally, we were noticing that things like kites on ice or winter candlelight ski events, that a lot of those were being canceled or postponed due to lack of snow or lack of ice. And we've seen pictures of like people parking cars on lakes and that ice not being thick enough and falling through. So we also asked these managers on their perception of event cancellations and event postponement. And again, I'm looking at for this slide, just looking at the past 10 years. It's a little bit flipped here. And so the increase means increased cancellations here versus decreased cancellations. So we see a similar pattern. Zone 1, again, the southern zone, is that they are seeing, there's 2 peaks in our curve here, one at no change and one at 11 and 25% increase in cancellations, including, again, one that reported greater than 50% increase in canceled events. Zone 2, there's also a significant number of cancellations that are occurring in the past 10 years. And again, zone 3, they, for the most part, see no change, just a slight increase in their cancellations. And so events that were completely canceled, we also look at events that were postponed. This would be an example of kind of adapting to new changes. So maybe they changed the date of an event so that it's in a period that would have more snow. So you can imagine something that you may have been able to do in December, you now have to move to January or February. And we saw, again, for the most part, no change, but for the central zone, actually, it was a little bit higher here, that there was an increase in the postponements. So these land managers are already noticing the impacts of climate change on winter recreation. So what do our climate models show us? So just like we looked at corn, we can do the same thing for winter recreation. We're looking at the percentage of the winter season where that cold temperature is below 0. Again, that would typically mean that when it snows, that snow does not melt because nighttime temperatures get below 0 and it refreezes. So our scale here is a little bit different. We're going from 39% or about 40% of winter being, those lows being above 0 to 100% of days where the temperature is below 0. This is the RCP 4.5. So this is looking at the Paris Climate Accord, that rosy scenario. And if we look kind of by zone 1 here in the south, we've got about a 90 to close to 100% of those days in winter below 0. And of course, as we get towards 2099, we see a significant reduction. So on our curve here, we go from about 110 days down to about 80 days of winter where the temperature is below 0. The central zone, we also see some moderate change. In the northern zone, even though it's the one that's the least impacted, there's still a decent impact by 2099, going down from about 100% of the days below 0 to about 90, 92% of them. Across the whole state, that's about a quarter or 25% decline in the number of days below 0 by 2099. So again, thinking about what this might mean for cultural practices, we're not erasing winter recreation under this scenario, but we are seeing a significant impact. Potentially in the southern zone, we start to see activities that can no longer be held. Under 8.5, just like we looked at corn as having a much more significant impact, here we see a much more, not quite as bad as it is for corn, but still a worse projections for winter recreation. So these curves start to get a little bit steeper, and we go from nearly 100% of those days being below 0 down by 2099, particularly in the southern zone, ending up to like 70 days out of 120 where those nighttime temperatures get below 0. So this, we're looking at about a third decline in the number of days where winter recreation could occur. Now, this proxy for winter, we have questioned a little bit. For snow to stay on the ground. So anyone that skis, you know that if you just get a cold day and it snows and then the next day is warm, that snow melts. And the following day, even though if it was below 0, that snow's already gone, you've lost your base and you're no longer able to ski. So one of the things that we're going to do next is look at the number of consecutive days that it stays below 0. So again, we're just looking at the number of days with that whole winter period. So we think this may be a little bit conservative, that 30% decline, and that for particularly the southern zone, the number of days in a row where the temperature will be below 0 will be relatively few across that winter season, and it may actually mean much more than a 30% decline in the number of days that you could actually cross-country ski. So right now, we think this is a little optimistic. So we're already, from the surveys, getting an indication that there's a correlation between climate change and winter recreation changes that are happening. The land managers are noticing this. They anticipate future change moving forward. So there's already changes in our cultural practices. For example, we see a lot more of those winter candlelight skis being called ski or hikes. And we've noticed anecdotally that when we go to these winter hiking ski events, it turns to be almost completely hiking because there's not enough snow for skiing. We're going to do some future research that kind of looks at other winter proxies. So again, the continuous number of days below 0. We also have precipitation data that we want to add on top of that. That's a much more sophisticated analysis, but that's going to be our next step. And what we haven't done, but what will obviously is that there's a significant cultural and economic impact by losing winter recreation in a lot of portions of our state. So what exactly will that mean? What will that mean for tourism dollars, the economies of some of these small cities and towns that count on some of these winter recreation? So what might be the impact on the Birkebeiner if it gets canceled 1 out of every 3 years? If you're interested, Eric's going to be producing an in-depth report that shows all the survey results and so forth. And you can send me an email and I'll make sure you get that when we're done with that. Now, back to those two models, the RCP 4.5 versus 8.5. It's been a while since those models have come out and projected their level of CO2 emissions in the atmosphere. And there's kind of a scary bit of data in that if you look at this black line, this is our actual emissions. Our actual emissions are tracking closer to this 8.5 modeled future than it is to the 4.5. So of course, everyone's aware that we pulled out of the Paris Climate Accord, something that was effective just a couple of days ago. President-elect Biden has said that we will re-add or rejoin the Paris Climate Accord. But there are already indications that a lot of countries besides the US are not meeting the requirements under the Paris Climate Accord. So right now our emissions, COVID-19, 2020 is a little bit of exception because of the decrease of economic activity, but we are on the track for that 8.5 doomsday scenario. We are closer to that model result than we are from that Paris Climate Accord. So we're still at a point where decisions that we make now can put us on one of those futures versus another. And this is the type of analysis that I think highlights that it is not too late, that we have a lot of people like, well, it's too late to do anything. It is not too late to have a significant impact on what places like Wisconsin will look like in 2080 or 2100. A few other kind of big picture conclusions. One is that we were really surprised that how difficult it was to get detailed information on winter recreation. That if, for example, in biology, they do phenological studies of, let's say, bird nesting. And there's a lot of concrete data on when birds show up, migratory birds show up in Wisconsin, or what time of year they nest. We thought we'd have similar types of information for human activities or cultural activities, particularly with all the, everything being digitized. We could not get consistent data to be able to look at changes across a 10 or 20 year period. And that there potentially needs to be a change in the way we collect and store this type of information so that we can better identify these trends and these cultural activities, not just the biological ones. It's clear that Wisconsin is already, quote, feeling climate change. So even though we don't have the catastrophic events that we see in California or Colorado, the change is here. We're already witnessing climate change, particularly in winter recreation. We did see in our survey results, stuff that I didn't report on earlier, that land managers are attempting adaptation. So what this would mean is if, let's say there's a cross-country ski trail that has a section that tends to melt out, it's south-facing. They're planting trees on the edge of that trail so that there's more shade on it. So perhaps 3 or 4 years from now, there's enough shade on that section of the trail so it doesn't melt out. And then we've talked about, Eric and I, the psychology of the slow crisis. So this is the analogy of slowly boiling a frog in water. And that in Wisconsin, the changes are occurring so slowly that it doesn't evoke a crisis response in Wisconsinites, in the general population. So they don't feel like there's a need for drastic measures, even though eventually the change will be so significant that it might mean that we lose winter recreation in the southern part of the state and potentially have to switch from crops like corn. So that's our glimpse at winter recreation in the state and what it might look like moving forward. I'd love to hear any questions you guys have about the research that we've done and other ideas on how we could use these downscale models to look at cultural, other human activities in the state. We'd be interested in hearing that. So thank you so much. And let's see, I will stop sharing here. Actually, I'll leave it up in case we want to look at some slides, but we can turn the muting off or use the chat box.
Thank you very much, Eric. That was so clear and understandable. I appreciate it. Does anyone have any questions?
I have a question about how it would affect ice fishing.
Eric?
Yeah, ice formation on the lake is similar to the way that snow would be preserved, so that nighttime temperature. So if nighttime temperatures get above freezing, you start to get a melting in the ice on the lakes. We didn't show that in terms of the survey results, but ice fishing was one that managers are seeing one of the most significant impacts on. So if we looked across those winter recreation activities, ice fishing was the one that had the most change that has already been observed, and they think we'll see the most change moving forward. So you could see the disappearance of ice fishing in some parts of the state within that modeled future within the next 80 years.
I have a question. I don't know how can you hear me?
Yeah.
You talked about the corn crop being decreased. Part of it was because there was so much rain that they couldn't plant the corn as early as they usually do.
Yeah, we, like thinking about the different ways that we could analyze this data, we looked at just those July temperatures because we could find clear empirical evidence of those high temperatures on corn yields. There's definitely other changes that might impact corn production. Just like you say, the amount of precipitation in the spring means that they can't get their corn into the ground, but there's also a lengthening season. So we've seen corn yields go up in Wisconsin, and one of the ways that we can explain that is by the longer season that we're getting. So even though they're getting in the ground later, they're getting more growing days into the fall. So there's actually some things that would, if we look at those climate change models, that for a while we would expect increased yields before we see those yield declines. So we think on that curve where we're going to see increased corn yields before the decline comes because of those warm, dry Julys and Augusts.
Thank you.
How do you use this data in presentations to DNR for their program planning?
We haven't presented any of this data yet to DNR. They are aware of it because so many of the people that we surveyed are DNR employees. And we actually had to get a statewide approval to do the survey of state parks and the managers in state parks. And so right now they're waiting for that report that Eric and I are working on. So we're interested to see the response we get once that report has been published. So you're looking at data right now that we've, some of these graphs we just completed like a month ago.
Had any luck, Eric, with the tourism industry? Do they collect data in any capacity about tourists coming in for winter sports or anything? Do they coordinate with other entities that manage that information?
The Department of Tourism does have a database of events. It's not collected in a systematic way, but they actually have that database going back about 10, 12 years. So we may actually try to get additional money to do more of like a historiography where Eric would go through like old newspapers. We were potentially going to have him go up to the northern part of the state and look through newspapers and microfilm for the last 10, 20, even 30 years, because 10 years is a fairly narrow window to look to see if we could see in those newspaper reports or the tourism data more concrete changes and evidence for that. But they've got that database, but it's not systematic. So there's no easy way just to like punch a few numbers, use some algorithms to summarize that. We'd have to go event by event and enter that into a database. And what we find too with some of that is that somebody will publicize the event, but the cancellation or the postponement of the event doesn't make it into the newspaper or doesn't make it into a record. So we can look to see if that event was planned. We don't necessarily know if it happened or not. And some of the surveys we would get back would be people that had only worked for 5 or 6 years at a particular department. And we encourage them to talk to colleagues and even people that had retired in order to get that 10-year window. So there's some institutional knowledge there that's really hard to get because some of these folks haven't worked 10 years at a particular park or place.
People, road construction consult you to see when they can start and when they'll finish their projects.
Say that again.
do people, engineers that do road construction for the state consult you as to when they can start and when they'll finish their projects because of the lengthening time of with the global?
We haven't, no, we haven't worked at all with any of the highway department, and I don't know if they look at climate data at all and how that might impact road construction projects. So I don't have an answer to that. Steve asks, what are the possible agricultural products we could grow in 2085? One of the crops that's really heat and drought tolerant is wheat. So if you look in, let's say in Kansas, there are a lot of places they grow wheat that corn doesn't do as well any longer. We used to grow wheat in Wisconsin back in the early 1900s. So we potentially return to wheat as a prominent crop. There's also a lot of opportunities for adaptation. So there are potential that we develop new hybrids, or there's an increase in the use of irrigation or other systems to actively cool crops during that pollination period. So we're looking at practices as they are right now, that it's not accounting for the type of human innovation that might exist within agriculture for us to change the crop itself so that it is not killed or have the same yield declines with those dry, warm Julys and Augusts.
I assume that you can get down to fairly specific areas of the geography of Wisconsin. How do the individual county tourism departments use you, or don't they?
Right now, we haven't really publicized the information much. There's once we get the report out, that report will be online. We can also make these maps interactive, and I'm interested to see once we do that. So imagine being able to zoom in and out and look at your particular county, that there may be some additional research or questions that would be relevant to planning it at a local scale. We did notice when looking at the anticipated change in the future as compared to the estimated change in the past, that we think managers see this in a linear fashion, that they've seen a certain amount of change in the last 10 years, so they think the next 10 years will be about the same. Our models, though, show a nonlinear change. And so there could be some years that it's not as bad, and then it could change quite a bit in a short 10, 20-year period. So I don't know if one of the results of this may be like, okay, there's more variability, and there could be a nonlinear change that you need to anticipate.
I was curious what controls you have in your analyses. Like, I don't know, just.
Lita, you cut out there.
Oh, I was wondering about what controls you have in the analyses. I don't know if there are different political cultures from the South to the North and perspectives that might be inherently affecting how the managers reply. I'm just curious about that as well, what controls you had.
We did get some indications from the survey responses that we saw, particularly in a couple of the open-ended responses, some managers saying things like, we don't believe climate change is real, and therefore that may have influenced or biased their responses to the survey. We did not control for that well, so there is the possibility that the managers, in particular in the northern part of the state, that thinking that climate change isn't occurring, you're more likely to say no change. We knew that if we asked explicitly about their views on climate change, we were told in pilot studies we would not get responses. So that was a compromise that was intentional to make sure that we increased the number of responses that we got. And since we were asking for an office to respond and not an individual, so we encouraged, let's say, the managers for a particular park to talk to everyone that worked in that park to kind of get them to a consensus. It was really difficult to control for some of those kind of political and personal views.
Understandably so. My dad had a question.
Are there any possibilities that forest fires may come to Wisconsin sometime in the future, or have fires taken place in the past?
Definitely. That's almost a guaranteed future for Wisconsin. Most of you probably know about the Peshtigo fire, and that was one of the most deadly fires and the most number of people ever killed in a fire in the US. And that we could see, we have had substantial fires in the past in Wisconsin, and there's no reason to believe that we won't have similar types of fires moving forward. There is, depending on how far south in the state you go, there's a lot of forest fragmentation. So we don't have the same continuous forest that we've had in the past to hold large, fast-moving crown fires. But up in the northern part of the state, there are plenty of large tracts of forest that could have similar fires to what we've seen out in the American West and California. So I think we're on that list. I can't tell you, and I didn't explicitly model that, of when we might see those types of fires in Wisconsin, but I think it's inevitable. So Steve asked about wheat in Kansas. What do you anticipate Kansas growing in 2085? Are the southern states going to experience hotter temperatures? We didn't look at the downscale models for the rest of the country, so I really can't talk about what would happen in Kansas or in southern states. Certainly, it's the number of extreme weather days. There have been other studies looking at the number of extreme weather days and the significant increase in those extreme days in the central and southern part of the state. Potentially, places like Phoenix become almost unlivable because there's temperatures so high that people cannot survive outside.
Any other questions?
Well, thank you all for your time today. And again, and Lita, please pass this along. If there are folks interested in, once we're done with that report and want to see that full report, you can send me an email and we'll add you to our list of folks that we're going to send that out to when it's finished. And then if you want to do your own downscale climate change analysis, those of you that want to pick up some computer skills, there's the link right there to download the same data that we used.
Thank you so much. And I appreciate you coming to share it today. So thank you very much. So we're going to send a survey.
Thank you.
Later. Watching, please forget about that. Diane, do you have anything that you wanted to add? Or are we going to click off?
Lita, I'm having a hard time hearing you.
Oh, my computer sometimes the speaker and mic don't work well. I wanted to thank you. Can you hear me better?
I can, thank you.
Okay. Yes, just thank you so much again for sharing this great information with us. And I think it's a great project that you did with your student. And I want to thank all the participants who came today. And Diane will be sending a survey out, a friendly reminder about that. And I think we're finished then. Is that right?
Yep.
All right.
Thank you.
Everybody have a great weekend. Thanks again for your time.
Great job. Thank you.
Bye.
Bye.
Oh, aren't you great?
Look at that red on her wall.
Okay.